Welcome to Creative World viewers. This is the very first video of Electronic Devices Conventional Current Version 10th edition by Thomas Floyd. From this video to onward, I will solve all unsolved examples and exercise problems of all chapters inside this book. So let's start with first learning assessment of chapter 2 2.1. Read the scenario. Learning assessment example 2.1. Assume that the diode in given below figure fails. What is the voltage across the diode and the voltage across the limiting resistor? This is the circuit diagram of diode. Inside this network, it is told that this diode opens. So modified circuit diagram according to the given instructions is provided here. This diode is opened. Now we have to calculate voltage across this limiting resistor and voltage across this open diode as well. So without wasting time, let's proceed towards the solution. This is the updated circuit diagram of this network according to given instructions in this scenario. So in order to calculate voltage across these two elements, we will apply Kirchoff's voltage law. For that purpose, we have to assume the direction of current along with its magnitude. I am assuming current I is flowing inside this network in clockwise direction. Now, according to assumed direction of current, make polarity notations across circuit elements in this network. We are following passive sign convention theory. According to this theory, current entering terminals will be taken with positive sign and current leaving terminals will be taken with negative sign. Polarity of this voltage source is given in this scenario. This terminal is positive and this terminal is negative. Now before writing KVL equation, we have to label voltage across these two elements. Voltage across this limiting resistor will be labeled as VR and voltage across this open diode will be labeled as VD. Now write KVL equation of this closed loop. We will start from here. Current entering terminal is negative, so voltage across this voltage source will be taken with negative sign. V bias will be taken with negative sign, minus V bias. Next element is current limiting resistor. Current entering terminal is positive, so voltage across this limiting resistor that is labeled as VR will be taken with positive sign. Next element is diode. Current entering terminal is positive, so voltage across this open diode that is VD will be taken with positive sign. This is the KVL equation for this closed loop. Place values inside this equation. V bias is 10 volt and the value of VR is I multiplied by 1 kilo ohm. Voltage across diode is taken as it is. Now if we observe, this is an open circuit, so current through this circuit will be 0 because of open circuit. So we can place the value of current inside this equation. I will be 0 ampere. Now the equation is formed. Minus 10 plus 0 multiplied by 1k plus Vd equal to 0. Take the product of 0 and 1k. The equation will become minus 10 plus Vd equal to 0. Place minus 10 on the other hand side of equal to calculate value of voltage Vd. That will become 10 volt. So voltage across diode will be appearing 10 volt. Now we have to calculate another voltage across limiting resistor. Voltage across this limiting resistor will be equal to I multiplied by 1k. I through this network is 0. So voltage across this resistive element will be equal to 0 multiplied by 1 kilo ohm. The product of 0 and 1k will become 0. So voltage across this resistive element will be appearing 0 volt. So this was learning assessment example 2.1. Thank you. See you again in next video.